Okay, with graphs 2, we're given a velocity versus time graph. Keep in mind this is not a displacement versus time graph. The horizontal axis is no longer a position, but a velocity equals 0. So when you're at the horizontal axis, you're not moving because the velocity equals 0. As the line approaches the horizontal axis, you're approaching 0. You slow down as you approach the horizontal axis. You speed up as you move away from it. Yes, if you're going more negative, you're just going to the left faster. If you're going more positive, you're going to the right faster. The first question asks us to identify anytime the cart is at rest. This is anytime the line crosses the horizontal axis. 4 seconds, 18 seconds. That's where we're seeing us cross the horizontal axis, so we're hitting a velocity of 0. Indicate every time interval for which the speed of the cart is increasing. Here we're looking for where is the line moving away from that horizontal axis. As it approaches it, it's slowing down. Once it crosses 0 and is going something other than 0, it's moving faster. Think of absolute value. If it's negative, it's just moving in the negative direction. It doesn't mean it's going less than 0. So kind of just marking this, and I mark the horizontal axis as a stop, and then just saying, hey, we're moving faster as we're moving above it, and we're moving faster as we're moving away from it below it. So the two line segments look to be, 4 to 9 seconds, and then again from 18 to 20 seconds. That's where we're speeding up. We're moving faster. And remember, speed, it doesn't have direction. When you look at your speedometer in a car, it doesn't tell you which way you're going, it just tells you how fast you're moving. Determine the horizontal position of X of the cart at 9 seconds if the cart is located at 2 meters at time equals 0. I'm going to start just listing everything that I know and what it's asking me for. It's asking me for the position, so the position is my question mark. It tells me my time is 9 seconds, and it tells me my X naught, my initial position, is 2 meters. So when I'm doing this, I'm going to look at the area under the curve of a velocity graph. The area under the curve gives me displacement, so I know how far I am from my initial position. So the area under the curve is going to be from the drawn line to the horizontal axis. If it's below the horizontal axis, it's negative, and if it's above the horizontal axis, it's positive. We've got two triangles, 1/2 the base times the height. If we add that up, we can kind of see where we are as far as where we started, how far we are from that starting point. The triangle that from 0 to 4 seconds is going to be 1/2 base times the height, 1/2 4 times 0.8. And then the one below the horizontal axis from 4 to 9 seconds would be 1/2, the base is 5, but now the height is -1. Do the math, we get 1.6. It was our displacement for the first 4 seconds, followed by -2.5, so we changed direction. We went from the positive to the negative, and we started at 2. So 2 plus 1.6 minus 2.5 gives us 1.1 meters from the origin. Last question, we want to sketch the acceleration versus time. Acceleration is going to come from the slope of the velocity graph. So what we want to do is look for every line segment, every individual slope, calculate those slopes for those time periods, and then graph them. So if we look at the first line segment, it goes from 0 seconds to 9 seconds. It's a continual slope, and we can say that the rise over run or change of y over change in x, it looks like it has a change of -1.8, and it took 9 seconds to occur. So we're going to say -1.8 over 9, and we divide that, we get -0.2. And if it's easier, let's just do all the math to begin with. So we can look at the second line segment, it goes from 9 seconds to 12 seconds, and we can see it goes from -1 up to -0.4, so it rose 0.6, and it took 3 seconds for that to occur. So the change in y over change in x, 0.6 over 3. The next line segment is from 12 to 17 seconds. It has 0 slope because it has 0 rise, so it's a 0. And then 17 to 20 seconds, it goes from 0.4 up to 0.8. So it had a change, a rise of 1.2, change of y of 1.2, had 3 seconds for that to occur from 17 to 20 seconds, so 1.2 over 3. And then 20 to 25 seconds was also 0. It had a flat 0 rise, didn't have any change in y, so it has a 0 slope. So now we have these values for those time periods. We can just simply graph them. So from 0 to 9 seconds, we're going to graph a line that has a value of -0.2. There we go. And then we're going to go up to positive 0.2 because from 9 to 12 seconds, the value was positive 0.2. And we're going to do that for 3 seconds. Then from 12 to 17 seconds, the value was 0, so we need to drop down to 0 and graph 0 for those 5 seconds. And then we need to go up to 0.4 from 17 to 20 seconds. Now we're up to 0.4, so we're going to do that for 3 seconds. And then the last segment was 0, because this was the acceleration. If our velocity is constant, we've got no acceleration.